All right, in this video, we are going to look at solving a system of a linear and a quadratic. So in the last algebra video we did, we looked at this particular problem, and here's my quadratic right here. It makes a parabola, y equals x squared minus 8. And then here's the line that we had, 2x plus 2y equals 8. And we looked at the fact that these two intersected in 2 points. So this one had two solutions. But that is not always true. That just happened to be true in this one, and I wanted to illustrate this particular idea of solving it algebraically by substitution. But you can also have something like this. So here's my parabola, y equals x squared minus 2x plus 5. Here's my line, x plus 3y equals 9. Now remember, the solution to a system of equations is the points that they have in common. It's the points of intersection. It makes both the parabola and the line true at the same time. But if you look at this one, you'll notice that they never intersect. So there's no point that makes the parabola and the line true at the same time. So for this type of system, the answer is no solution, because at no point do they cross each other. All right, we can also have this kind. Here's my parabola, y equals 2x squared plus 4x minus 1. Here's my line, y equals negative 3. In this case, it happens to be horizontal, and you remember a horizontal line has a y value but not an x value. So if I wanted to find the point of intersection, let's look at doing this a couple of different ways. First of all, I can use the fact that I remember from Algebra 2 the formula for the vertex of a parabola. So if you don't remember, write this on your paper. H equals negative b over 2a. Okay, and remember a, b, and c, just like when we were factoring. There's a, there's b, there's c. So if I type this, or if I substitute into this, b, you can see here is 4. So in my formula, I'm going to put negative 4 because it's the opposite of b. And then in the denominator, 2a, and a in this case is 2. That's the coefficient on the x squared. 2 times 2 is 4. Negative 4 over positive 4, negative 1. So h is the x value of the vertex. I already have the y value of the intersection point here. I just needed the x value. So I have the point negative 1, negative 3. Okay, but it's not always going to be the vertex. This one happens to be the vertex, but sometimes it won't be. Sometimes it'll be another point, and your line will be what we call tangent to the curve. It'll touch it in one point over here, but it won't go through. In that case, the vertex idea won't work. So if you have that, you're going to have to use substitution like we did in the last video. So I'm going to take this negative 3, and I'm going to substitute it for y. If y is the same thing as negative 3, then I can substitute negative 3 here. Okay, so let's do that. Negative 3 equals 2x squared plus 4x minus 1. Okay, well, this is a quadratic. I have x squared as my highest exponent. So when I solve a quadratic, I remember that I need it to be equal to 0. So I'm going to add 3 on both sides. Negative 3, positive 3 cancel out. That gives me that 0 that I needed, so I can use my 0 product property. Negative 1 plus 3, positive 2. Okay, so let's factor this. Remember, our first step when we're factoring is always to look for a GCF. So 2, 4, and 2. This one does have a GCF of 2. Let's factor that out. 4 divided by 2 is 2. 2 divided by 2 is 1, so that's why I have a 1 here and also an understood 1 here. You can put a 1 on your paper if you want to, but it's understood to be there. Okay, now we need to do A, B, and C on this quadratic. So let's do A equals, B equals, C equals. And remember, to find A, B, and C, I'm going to use the values inside my parentheses. So A is going to be 1, B is going to be 2, and C is also going to be 1. So I'll multiply A and C together. 1 times 1 is 1. So I need two numbers that multiply together to be 1 and add together to be 2. Well, I'm kind of limited in my choices. Things that multiply together to be 1, 1 and 1. And fortunately, 1 plus 1 is 2. So that's the two numbers. I'm going to substitute for B. Remember, this is the one we substitute for. That 2 on the outside just stays there. X squared plus 1x plus 1x plus 1. And y'all know 1x and x are the same thing, so if you just put x, that's okay. Now I'm going to split it in half, right in between the x and the plus. And then I'm going to factor out the GCF of both sides. So I still have that 2 on the outside. Looking at these, the GCF of those is x. So they both have an x. And remember, when I factor, I'm really dividing. And when you divide, you subtract your exponents. 2 minus 1 is 1, so I'll have x to the first right there. And right here, 1 minus 1 is 0. So that doesn't mean I leave it blank. It doesn't mean there's nothing left. Think about when you divide, like 3 divided by 3 is 1. 5 divided by 5 is 1. So when I divide here, x divided by x is 1. You can also think about it that anything raised to the 0 power other than 0 itself is 1. So when I subtract my exponents, 1 minus 1 is 0. So x to the 0 power is going to be 1. All right, now let's look at these two. The GCF of these two is 1, so I'll put 1 right there. And again, you can put the 1 on that x or not put the 1 on that x. It doesn't matter. But when you divide by 1, nothing changes. Okay, so I notice I have x plus 1 in both of my parentheses. And I look at what's on the outside. Well, that's going to be x plus 1 also. And my 2 is still there. Okay, so now I'm going to use the zero product property. So that's where I set my factors equal to 0. I don't need to set 2 equal to 0 because 2 doesn't equal 0. You only need to put things that have an x in it. Only the things with the variable set equal to 0. So I just ignore the 2 because it doesn't have a variable. And I move here. I'm going to move over on the screen so I've got some space. X plus 1 equals 0. So x equals negative 1. Okay, now normally I would set both of these equal to 0, but look, if I set x plus 1 equal to 0, I'm just going to get negative 1 again. So there's no reason to get negative 1 twice. Once I've already got it, I've got it. And you remember your answer to a system is the point where they cross right here. And a point is written x comma y. So in this case, negative 1 comma negative 3, which is exactly the same thing that we got before. So x comma y for my answer. Okay, let's do this one. So this is one that came out of Delta Math, and I'm going to show you how to put this one in so that when you do your homework, you'll know what you're doing. And it's going to ask us in Delta Math to solve by graphing. So I've already got the quadratic right here, y equals. I don't need to do anything with that one. But this one, I need to get y by itself. Because when we graph, remember we use the slope-intercept form. So that means I need to get y by itself. So I'm going to subtract 4x from both sides. And I have a negative still on that too. Don't accidentally drop your negative. All right, divide by negative 2 all the way across, working to get x by itself. Negative 4 divided by negative 2 is positive 2. Negative 10 divided by negative 2, positive 5. Okay, so now I'm ready to graph my line. All right, so let's look at what we see in Delta Math. Let me scoot that over just a little bit. Okay, now look at the directions here. It says you can move the parabola by dragging the dots. And you can see I have 2 dots, a green one and a blue one. Well, the green one is on the vertex, and the blue one is just some other dot. So I need to find a place where I'm going to put the vertex dot, and then I just need some other point on the parabola. It doesn't really matter what, as long as it's small enough to fit on the graph, it's fine. So let's go back and find the vertex of this parabola. Okay, so I remember from what I had on the screen just a few minutes ago that to find the vertex, I'm going to use the formula h equals negative b over 2a. All right, and here's my a, b, c. So b in this case is positive 4, so I'm going to get negative 4. A is negative 1. I'll substitute that in there. So I get negative 4 over negative 2, which is positive 2. Okay, so positive 2, that's the x value of the vertex. But if I want to put my point in the right place, I need an x value and a y value. So to find the y value, I'm going to take this 2, and I'm going to substitute here for both of the x's to find the y that goes with it. So negative 2 squared plus 4 times 2 plus 5. Okay, so you might be tempted right here negative 2 squared, you might be tempted to put positive 4 because negative 2 times negative 2 is positive 4. But look at the way this is written. Do you see that the negative is outside of the x? Order of operations tells me I need to do my exponent first and then multiply. So I'm going to square 2, right? The number I got right here is a 2. I'm going to square 2 and then make it negative. So right here at the beginning, I'm going to get negative 4. 2 times 4 is 8 plus 5. All right, negative 4 plus 8 is 4. 4 plus 5 is 9. So my vertex is at the point 2, 9. So that's going to be my green dot. All right, now remember you had also that blue dot. You have to have some other point. It doesn't matter what. You just have to have some other point to go with it. It's usually a good idea to pick one that's close to the vertex. So instead of using an x value of 2 like I have in the vertex, I'm going to use an x value of 3. And I'm going to substitute into the equation. Okay, so I've put 3 this time in place of my x's. Okay, now remember right here, look at this one as an example. Should I get positive 9 or negative 9 right here? Well, I should end up with negative 9 because 3 squared, order of operations, and then make it negative. So negative 9 plus 12 plus 5. Negative 9 plus 12 is positive 3. 3 plus 5 is 8. So my point for my blue one is going to be the point 3, 8. Okay, so let's go back onto Delta Math and let's graph it. All right, so I'm going to move my green dot, move my screen up here a little bit. I'm going to move my green dot to the point that we said is our vertex. And if you forgot that, that's this one here. That's 2, 9. So I'm going to just drag the green dot to 9. All right, 2, 9. All right, and then the blue dot. The blue dot is this one. The blue dot is 3, 8. Okay, so let's move the blue dot to 3, 8. All right, so there it is, 3, 8. And the green dot is 2, 9. Okay, so I moved the parabola by dragging the dots. Now it says graph the line by clicking twice. Okay, now this is similar to what we did before. Let's look back at our line. Here it is right here. Y equals 2x plus 5. Okay, so remember, I'm going to put a dot on 5, put a dot on the y-intercept first, and then from there, I'll count the slope. 2 is the same thing as 2 over 1, so I'll count up 2 and write 1. All right, so let's put a dot on 5, and then I'll count up 2 and write 1 and click. Do you see how I clicked twice, and there's my line. Okay, so now remember, the answer is the point where they intersect. So down here, it's going to ask me, how many solutions do I have? Well, they intersect here, and they also intersect here. So that's 2 solutions. So click on 2 solutions, and then it'll ask me what they are. So this one first, x and then y. So my x value is 0. My y value is 5. 0, comma 5. Okay, now let's find the other one. The other one, they intersect right here at the green, which we know to be the vertex. It's the point 2, 9. So let's type that in there, 2, comma 9. All right, and then we'll submit our answer. And yes, we got it right. So that is how we will do that type of problem. Okay, let's spend just a minute looking at another one. All right, this one is already in the correct form. I don't need to do anything. So for the line, remember I click twice for the line. We'll do the line first this time. So I'm going to start at -3. And then from that, I'm going to count up 2 and write 1. So there's my line, -3 on the y-axis, up 2 and write 1. And then for the y-intercept, for the vertex of the parabola, remember we have to use that formula. Clear that out. There it goes. H equals -b over 2a. If you did not already write that formula on your paper, go ahead and write it now. We're not going to have time to finish this one. The video is going to turn off, but that's the formula that you would use.